Here's my final project. It is data cleaning for informed Craigslist car purchases. The problem with Craigslist is that there's so much information, and people spend a good amount of time searching for good deals, and there's so many options, and it's hard to sort through them and get data that's best for them. So I created a tool that will aggregate Craigslist data and help users sort through listings and have a better understanding on what is out there and better tools to sort and get insight and user feedback. Craigslist has been around since 1995. It's headquartered in San Francisco. The founder is Craig Newmark. And essentially, Craigslist, most people, it's a common website. You can buy, sell, rent, find jobs, anything on Craigslist. It has 60 million users, 50 billion page views a day. There are 80 million ads posted each month, and for vehicle listings, there are over 3,000 in the Hartford area. The software and technology that I used for this project, predominantly Python and PySpark. I also used SQL to make my search queries and created a scrapey web crawler that was able to aggregate the information from Craigslist. I used matplotlib to show my data. I ran my code on Ubuntu. I have a VM with the Linux 16.04. The data that I used for this project comes from two different sets. What I wanted to do was take the Craigslist data and get more useful information out of it. Whenever you're searching for data, you don't necessarily know what the fuel economy of the car is, and so I wanted to be able to standardize this and make it easier to search. So I took a fuel economy data set from a government website that has all makes, models, and years from 1984 to 2019. The link is provided below. There are over 40,000 vehicles in this listing. I've learned that it's not completely inclusive, but it does a pretty good job. And there are 83 different columns of information. Not all of them are full, but there's a lot of information that comes from that CSV. When I cleaned this data set, I condensed it for cylinders, displacement, drive, fuel type, make, model, miles per gallon, city, miles per gallon highway, transmission, vehicle class, and year. I can quickly show you the website. Here's the fuel economy from the U.S. Department of Energy. I came down here and downloaded this CSV file. The data in its full form has all these different columns, and then I pulled out which ones I want in my code. And I saved it as fuel simple, and it looks like this. So it has the number of cylinders, displacement, drive, etc. And here's the make, and all the information that is useful for the search and that I'll use later to join with the other Craigslist information. And my second big data set was from Craigslist. I brought raw data in with a search. All you do is take the URL and search from there, and it will continue through multiple pages until it gives you an aggregated list. I spent a long time cleaning this data. That was a big portion of my project, and I ended up taking out the title, URL, price, address, VIN number, odometer, condition, etc., and to match with the other data set. So here are the overview of the steps. The first major step was to prepare the fuel economy data set, then gather and clean the Craigslist data, and then join the two data sets to get the informed learning. And then here's just a screenshot of Craigslist with all the different tags. So the first one, I showed you the fuel economy website. And what I did to clean this data is the transmission information wasn't consistent, so I had to go through and make sure it said just manual or just automatic. I removed duplicates. There were a lot of occurrences where there was the same make, model, and year in transmission and number of cylinders, but Craigslist doesn't have enough information to always say here's a displacement, and there isn't enough information to differentiate between these in the fuel economy data set. So I ended up just removing them and took the worst possible condition, and users can use this as a base and continue from there. Then I only kept useful metrics, and I saved this out as a CSV. Oops. I used Python to get this data. Oops. So that didn't work. The next step was Craigslist, and I created a scraper and called it vans. I created a Python file called vans. It has a job spider class and two functions called parse and parse page. How this works is there's a start URL that's directly from Craigslist, and that is put in there, and then the spider will run through every listing and then every page and spit out the output for you for each listing. And in order to run this, you do scrapey crawl vans and then your output file. The scraper that I created will only keep good output. The code is set up to find the data that I want, and I will go ahead and show you the code example. So I'm going to take So I have a folder called Craigslist, and I showed this in my documentation on how to start with a scraper. And here is inside, I have my settings where I'll have what columns I want to output and my list of spiders. I have a spider called vans.py, and here's the initial class I was talking about, the jobs.spider, and here's the output name. It's important that matches the title, and here's my start URL. Then I have the parse, which will iterate over the URLs and then go to the next page using button next, and then parse page, which is what spits out the output from each listing. Then in here I have all my logic for taking and cleaning that data and adding data that wasn't necessarily there. So on Craigslist, if you go to a listing, they have a title, the price, the year, and the tags over here, which are very handy: cylinders, drive, fuel odometer, status, transmission, and type. But they don't have a tag for the make, model, or year. So all of that has to be taken out from the title, description, etc., but also make sure that it's a good match. A lot of times users will put that information in the description, and that is fine. I also used the description in a cleaned version to get information if it was missing, such as the number of cylinders, because I decided that was important for having a good match. So here's my code. I'll quickly go through this. So I create a dictionary in order to help find the make, model, and year. There are a finite number of makes. I think there are 132. There are like 16 different years, and I'll create a dictionary that will sort on for, let's say, the Kia in 2004. It will have a list of all the different possible models. That way I'm going through and individually searching for them. It's a condensed list. So here's where I'm going through. Here's part of the scrapey work, is that I'm just going through and getting the URL, the title, the address. Those are the easy ones. And then other tags such as price and description. The next ones are given in these tags on the side here, and you can inspect the element to see how this is all set up. And so in the span you'll see the drive, and then it's forward drive, front wheel drive. You can see down in the inspected element. So in my code, what I have is some logic that will go through and get all the tags and get all the values and make sure that it's in a clean manner, put them in a dictionary, and are all good to go, minus make, model, year, etc. So what I did for those is I created a search string that includes the title, the drive, and the description to help get some of that information. And here I have some logic to find the model, logic to get the year, and you can see here I'm using search title and search list to enable to root out what the year is, and going through and say none if it doesn't find a good match. For what I found is that make and year came out very well, and there were not many issues with that. There were some issues if the user described models they wanted, makes they wanted to trade for in the description, but I was able to clean that up. The model is a little more difficult, so I had 3 different methods. My first one was just straight out search for the model, and then I searched for the model plus the drive given by the user on Craigslist, because oftentimes that's how the fuel economy data was set up, and it made it more exact. If there was a front wheel drive and a rear wheel drive, I could get the match. And then next I have a smart search that will go through and individually count the number of times that the model words show up in the text and choose the result if it is greater than the other ones. And then I search for the cylinders just to make if it's not there, just to make sure that I have a good match, and then return the data. And then all I have to do to run this is run scrapey crawl vans, and have to make sure I'm in the right folder, and then all I have to do is call scrapey crawl vans, and oops. Then all I have to do is call scrapey crawl vans, and that will run through all the data to produce output. I will stop that. Okay. And then the last step is joining the data. So after the two data sets are created, the files can be joined. The correct functions need to be imported, and then creating the data frames. And then you have to do the join. So I chose to join on make, model, year, transmission, and cylinders. The join should be good because of all the cleaning, and here's the join that I used. And then you can run queries. And so I can go to my VM and take the join information, and I will go ahead and run it. This doesn't take too long. This is all in PySpark, and so then here I'm just printing out the total number of counts. And then if I do show 20, do this on the shorter one. So this shows that there were 1,420 counts. And then here are the top results. And so what you can see, I just chose some of the key information, otherwise it would expand far across the screen. The Honda Insight, the year 2000, with the price, the miles per gallon, the class, and then the condition. So if the user wanted to say not include anything but excellent cars, they could do that as well. And then what I would do in order to be able to see the information but then also be able to visit it on Craigslist is then print out the same thing but with the URL. And then what I could do is take the URL, copy that, and then go visit Craigslist. I can check it out. And in fact, it is the Honda Insight 2000, $1,500, conditioned fair, and you can get more information and then the pictures, etc. And then the user could go back and pick the next one or do a different search. So here's what I was showing you. Here are the preliminary results. And the URLs. And then here's the picture that I was showing you online. So then what I did was took these results and put them in matplotlib just for some more information. You can see, as expected, the greater the engine displacement, the less efficient the car is. I thought it would be interesting to plot the price versus a condition. There's not always a clear result, but excellent vehicles might be priced more than the other ones. I just thought it might be an interesting addition. As you might expect, there is some correlation between year and price. Newer vehicles tend to be a little pricier. And there seemed to be no correlation between miles per gallon and price of the vehicle. So here's just an overview of the code. So I had prepare fuel.csv, vans.py, that was the scraper that I demonstrated, and then I have my join code that will bring it together as you're seeing on the last few slides. So my final results is that the tool works. It does successfully search Craigslist for a vehicle, and the user can then apply search metrics to best apply that to their needs. This should decrease search time and make the user feel more comfortable with their decision. It's great because right one after another you can see two of the same cars. So we have two Honda Insights, as you can see from these initial results, but they have different prices. They are the same year, and one's excellent and one's in fair condition. So the user can go visit both of those and see which one's better for them. Since the users are behind the input in Craigslist, the code is not infallible and there are errors, especially when I was doing for more niche searches like looking for vans. A lot of times the vans weren't in the fuel economy dataset and it would match on something incorrect. So the results do need to be taken with a grain of salt, but they are good for providing user feedback and data trends. Lessons learned, pretty good appreciation for what it takes to have good data. There are so many irregularities and it did take quite a long time to make sure that the data was worth searching. And especially doing a more regular search caused even more problems, so more work will need to be done to make sure that those are good. In general, the project was a success and data was able to match. In the future, I think it would be interesting to do more location-independent searches, so you could search for cars in New England, I guess New York, Hartford, Florida, Texas, California, and just plot all the results next to each other. It wouldn't take any more time to run. You just need the time to actually sort through that data. And then fuel economy can be downloaded from the website is what I did, but further along in my work I discovered that you can also just import it directly into Python, so that would be good future work to make sure that's always up to date. Here are my references, and that's my project.